Our topic is data types in C language. Here data types represents type of the data. A variable contains the type of the data. For example, if we say int a, that a is the variable identifier, that variable will be indicated with the type, data type. Which type? Integer data type, int a, that is the int data type. For example, float b, that b variable is the float type. In that float we will have integer part and fractional part. So here a variable contains the type of the data. The data may be numeric or non-numeric. Sometimes int a is 6, or we can represent char ch is equal to a. We assign a into ch. So that data may be numeric or non-numeric. Here basic data types are integer, float, char, double and void. Data types are classified into 3 types. Here you see void, integral, floating point. These are the primary data types, basic data types. These 3 are the basic or primary data types. You see here, primary or basic data types are void, integral and floating point. You see, now we are going to discuss about basic data types. In that, data types are classified into, basic data types are classified into void, next integral, floating point. Here void means it doesn't return any value. Next, integral. Under the integral we have boolean, character, integer. Here boolean means true or false values. True will be represented with 1, false will be represented with 0. Okay, you see here character. Next, integer. You see here, for the void, here I have given syntax. It will not accept any values and not return any values. It has no values and no operations for the void. Next, we will discuss on integral part. You see here integral part and floating point. So now we will discuss under the basic data types integral part. Okay. You see here under the integral data types we have 3 types: boolean, character type, integer type. Boolean means it represents true values, 2 values, only 2. They are true or false. Here 0 represents false, 1 represents true. Okay. Next, here boolean program. You see here hash include stdio.h. This hash is called preprocessor directive. It's a program. By using this program we can define standard functions in stdio.h, printf and scanf, in conio.h, console input output header file. In this we will have clear screen and getch functions. Okay. If we want to work with bool, we have to write here hash include stdbool.h. Hash include stdbool.h. stdbool.h header file is used for these bool variables. Okay, bool x is true. So true means 1 will be assigned into x, false 0 will be assigned into y. Boolean values are %d is the format specifier for the integer value. This x will be stored. Okay, what is the x? True. Here 1 will be displayed. Okay, next y value 0 will be displayed here. Okay, here /t. Here output first 1, next /t means 7 spaces will be displayed. Here you see our output. Our output here you see boolean values are 1, 0, 7 spaces. After 1 /t tab space, 7 spaces will be displayed here. Okay. Next, here you see if I write integer, we have to write return 0. This getch will not function in dev C++. Okay, this getch will function in turbo C only. Next, character data type. Character data type, here you see char and wchar underscore t. Now it is not using wchar underscore t is not using now. This is outdated. Okay, the format specifier for the char is %c. Okay, here you see here in this character we use ASCII values. For example, char ch is equal to, in single quotes, small a. That small a represents 97. Okay, here character only, but we assign character only, but every character will have ASCII values. Every character, whatever I assign the character to the variable, that character will have ASCII values. That ASCII stands for American Standard Code for Information Interchange. Here, the size of the character is 1 byte. 1 byte means, you see here, all these are the bits. How many? 8 bits. 0 to 0, 1, 2, 3, 4, 5, 6, 7 bits. 8 bits is 1 byte. Okay, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, like that up to 2 to the power of 7. That means 256. Here on number line, we can represent minus 128 to 127. In middle, 0 will be there. So for the signed char, we have signed and unsigned. Here, this is the signed char. For unsigned char, up to 256 value. Maximum value for the char, 1 byte. That means 256 values. You see here, this is the number line. Okay, minus 128 to 127. In between, 0. Next, integer data types. You see here, there are 4 integer data types. They are int, long int, long int. You see here short int. Short int size is 1 byte. The size 1 byte means total 8 bits. 2 to the power of 0 to 2 to the power of 7. 256 na. So on a number line we can represent minus 128 minimum value, maximum value 127. For integer 2 bytes. That means 16 bits. 0 to 15. 2 to the power of 15. Okay. So this is the representation on a number line. Minimum value minus 32,768, maximum 32,767. Similarly, long int size is 4 bytes. This is the size. Long int size in bytes 8 bytes. Size minimum value, maximum value. These are the integer sizes in bytes, and values for the integer values. So we have short int, long int. Okay. Next, for short int, type specifier or format code is %HD. Here %D. Here %LD. Here %LLD for long int. Okay. Next, you see here short int %HD, int %D, long int %LD, long int %LLD. These are the format codes or type conversions or type specifiers or type specifications. Okay. You see here. Next, floating point types. Floating, it contains integral part and fractional part. Okay. You see here 3 types of floating point types. One is float, double, long double. Here you see for the float size in bytes 4. This is the minimum value. This is the maximum value. That means 4 bytes means 8 into 4, 32. That means 0 to 2 to the power of 31. The value on the number line, minimum value and maximum value. This is the left side of the value. This is the right side. So we cannot exceed the value for the float. Here max value cannot be exceeded. Okay. Next to double also, size in bytes 8. This is the minimum value for the double. This is the maximum value for the double. For long double, you see here, this is the size in bytes 10. For long double, minimum value and maximum value for the long double. Next, format codes or type specifiers for the float. Floating point representations. Float %F, double %LF, long double %LF. Okay. Next, here you see here for imaginary values we can represent like this. Okay. I square is -1, I is the root of -1. Okay. Complex value, what is the complex value? A plus bi. Here a is the float value, bi is the imaginary value, total a plus bi is the complex value. If I want to represent a complex value in the floating point representation, a plus bi is the formula. A is the real value, that is the float value. Bi is the imaginary value. Here I square is -1, I is the root of -1. Here you see representation for the imaginary float complex, double imaginary, float imaginary, double imaginary, long double complex, long double imaginary, float double, long double imaginary values. Next, representation for the imaginary values, 14f plus 16f into I for the float complex, double complex, long double complex, like that. This is the value in mathematical representation. Okay. In C language we have to give like this. This is the complex value a plus bi. You see here data types are classified into 3 types. Now we discussed basic or primary data types. What are the basic or primary data types? Void means it doesn't return any value. Next, integer. In integer, signed and unsigned. Next, character type, floating point type. Okay. In floating point, we have real value a plus bi. A is the float or real value plus bi. Bi is the imaginary value. A plus bi is the complex value. Like that we write. Next, second data type is user defined data type. User defined data types, that is type def and enum. We have three data types. Basic data types are primary data types. Second one, user defined data types. Third one, derived data types. In further classes, we discuss about user defined data types and derived data types. Okay, here under user defined data types, we have type def and enum. Type def means, you see here, instead of integer, float, char, we can define our own data types. Type def, we can define our own types. You see here, type def int SNO. Here, instead of int, now I will use SNO as integer, SNO a comma b. It represents, SNO will act as integer type. Why? Because this type def is a keyword or reserved word or predefined word. With this, I used SNO as int. So now SNO will act as integer type. You can use any identifier, any variable name. Next one, enum. Enum is the enumerated constant values. Enum is the keyword or reserved word or predefined word. Next, enum. Sample is the user defined name. You can give the name any name, sample or test any name. Mon is equal to 1, two is 2. Close, here begin and close. Day 1, day 2 are the variables. These two are the enumerated constant values. Okay, enumeration is used for represent enumerated constant values. You see here printf Monday is percentage d, day 1. You see here, here this mon is equal to 1 will be defined in day 1. If I mention day 1, then that mon is here 1 will be displayed here. Monday is 1. Why? Because this constant value will be represented with these variables. Day 1, day 2 are the variables. These mon and 2 are constant values. Okay, with these variables we can display that constant values. Here Monday is equal to 1. This mon 1 will be assigned to day 1. Q is 2 will be assigned to day 2. Next, one more derived data types. Third one. First one basic data types. Second one user defined data types. Third one three data types. Third one derived data types. Arrays, structure, pointer, union. Here struct is the keyword. Okay. All these second and third data types will be discussed in our further classes. Next, you see here char or signed char. For the signed char, we can represent with minus and plus. For unsigned char, we can represent 0 to 255. Like that for integer also, signed int, unsigned int. Okay. Same for all, we can use signed and unsigned. Sign means on a number line, we take left side value and right side value. Unsigned means only right side of the values. Right side to the 0 values are the unsigned values. You see here, these are the format specifiers for the integer, percentage d, float, percentage f, character, percentage c, long integer, percentage ld, unsigned integer, unsigned, percentage u. Signed means plus or minus values. Unsigned means only positive values. Double, percentage lf, string, collection of characters, percentage s. The string is not a basic data type, it is a derived data type. You see, for hexadecimal numbers, we will discuss about hexadecimal numbers later. Okay, to convert into machine language, in number system topic, we discuss this octal number in number system to convert into machine language. Octal, hexadecimal, decimal, we discuss in number system. In further classes, we discuss. For floating point or exponent values, we use percentage e. For short integer, we use percentage hd. Okay, like that we use formats or format specifiers or type specifiers in data types. You see here size and range data type values. For signed char, you see here with sign, unsigned char, all positive values. Short int, unsigned short int. Here by default, this is the signed short int or signed short int. Okay, here int or signed int. By default, it is signed int only. If I give int, by default signed. If I want to give all positive values, I have to mention unsigned int. Okay, by default it is signed, but for unsigned we have to mention. If I give int, that is the signed int. For unsigned, we have to mention completely unsigned int. For all these signed and unsigned values are there once you see this.